Okay, so molecular compounds, just a brief overview of what those are. Um, so molecular compounds, again, those are also pure substances that form when two nonmetals in elements combine. So again, we had that dividing line. I like my periodic table better because it has a really clear dividing line. But two nonmetals means that it would be two things from this side of what's called the staircase. So this really thick black line is called the staircase. So it'd be two elements on the right side here combining together. Now what's kind of interesting is if you look in the top right hand corner of this periodic table, all of these elements all have a negative charge. And so you might be thinking, and hopefully you are thinking, how is it possible that those two can form a bond when we said the most likely bonds that are formed are like when you have a +2 and a -2 charge? So how can two things with negative charges be attracted to each other and form a bond? And the way that that occurs is that occurs by them actually sharing the electrons to form small groups, and those groups are called molecules. So they share electrons to form small groups called molecules. And that's where this name molecular compound comes from. Some of the properties of molecular compounds. They can be solids, liquids, or gases at room temperatures. They're usually good insulators and poor conductors of electricity, and they have very low boiling points. And so scientists call this sharing of electrons between atoms covalent bonding. So that's another key term that I will use a lot. I might not actually call it molecular compounds. I might call them covalent compounds as well. Those are both the same term. They mean the same thing. And the way that atoms bond, there's two different models that we'll use to describe them. One is Bohr diagrams, which we have experience with, and the other is ball and stick models. Do I have a blank slide? Yes, I do. Okay. So we're going to do kind of the most simple example that we can do, which is H2O. And the reason I'm going to do H2O is it hits on a couple of points here. The first point is that this molecule is made of 2 hydrogens and it's made of 1 oxygen. And so in order to actually show how this works, we need to draw out the Bohr diagrams. So if I go to this periodic table, which is over here, if I go to this periodic table, I can see oxygen has an atomic number of 8 and an atomic mass of 16. So when talking about oxygen, the pen here. So 16 was the atomic mass, 8 was the number of protons, 8's the number of electrons, so the number of neutrons will be 16 minus 8, which is 8. Hydrogen, if we go back to it, has an atomic number of 1 and also an atomic mass of 1. And so as such, when we do our pen, P-E-N, we say that this has 1 proton, 1 electron, and then 1 minus 1 is equal to 0 neutrons. So when I'm drawing these, I would want to draw oxygen first here. And I'm going to do something different. I'm going to put P plus is equal to 8, and 0 is equal to also 8. And then I'm going to draw my second ring here. Now what I'm going to do is I know that I need to draw 2 hydrogen Bohr diagrams and 1 oxygen Bohr diagram. So for this oxygen Bohr diagram, I know I have to draw 8 electrons, so I'm going to do those actually in a different color. I'm going to do those in a light green color here. Oops, wrong button again. Yeah, are you not on Discord? Oh my word, this thing is having issues. Oh, I know why it's doing that. Can you see that now when I click on that? Okay. Okay. So 2 hydrogens, 1 oxygen here. is what we need to draw for H2O. So I have 8 electrons. I'm going to draw my electrons as a lime green color. So 1, 2, 3, 4, 5, 6. And what I'm actually going to do is I'm going to put my electrons, there's a reason I'm doing this, but I'm going to fill in my other 2 electrons here. So I've given oxygen 8 electrons. So this, as we said, is oxygen. So I'm going to put a little O beside it for oxygen. Then what we want to do is we want to draw our little hydrogen Bohr diagrams. But these Bohr diagrams, I'm going to draw them really, really close together. Actually, I'm going to draw them even closer together than that. I'm going to draw it right here. So that'll be my one hydrogen. This will be my other hydrogen. So here is hydrogen, and here is a hydrogen. I'm actually going to write these names out just to make it clear. Okay, and what I know is that these guys will have number of protons equal to 1 and number of neutrons equal to 0. Number of protons equal to 1, number of neutrons equal to 0. When I'm drawing these electrons, what is going on with molecular compounds is they're actually sharing these electrons. So when I draw these electrons, I'm actually going to span them across like this. And I actually need to redraw that black circle there. So let's redraw that black circle so that it's even closer, like this. So there's hydrogen, and then we'll draw the red electron like this. So hydrogens are red, and oxygens are the greens. So what's actually going on here is these 2 electrons, so at this interface, which I'll circle here, between hydrogen and oxygen, those 2 are actually sharing electrons. And so this sharing of electrons allows oxygen to have 8 electrons in its outer shell, and hydrogen to have 2. Hydrogen to have 2 electrons in its outer shell. So without actually giving up and having a charge, neither of these elements will have a charge. Because they're not actually giving up or receiving the electrons. Instead, they're just sharing them. Hydrogen is saying temporarily you can act like you own this electron. And what that'll do is it'll give you 1, 2, 3, 4, 5, 6, 7, 8 electrons in this outer orbital. And oxygen's saying the same thing to hydrogen. It's saying you can borrow this lime green electron here so that it looks to you like you have 2 electrons in your outer shell, which would mean that this first shell would be full. So that's what molecular compounds do. They are different in the sense that they are not actually giving or receiving electrons. Instead, they are sharing those electrons. And so when we look at diatomic molecules here, we'll get to that in a sec, but basically that is how molecular compounds work, is they are going to share electrons between each other. With ionic, it was completely giving or receiving electrons. With molecular, it is just a sharing of electrons that is occurring. We will talk more about these diatomic molecules, but basically what these diatomic molecules are is they can never be alone. And the reason that they don't want to be alone is they are very, very reactive if they are alone. And so these elements, whenever you see them in nature, are going to exist as pairs. This oxygen here, O2, is actually the oxygen that you breathe in. You're not just breathing in pure oxygen. You are actually breathing in O2. And so what we will get to eventually with this unit is we will get to both the chemical names and chemical formulas of each of the compounds that we are developing. So when we're looking at this bottom section, what becomes incredibly important for us to be able to identify is how many of each element we have in the following compounds. And kind of a rule that you need to know is that if there is no number beside an element, there is one of them. Chemists are really lazy. We don't like to draw our little ones. So when we look at H2O, we would say we have 2 hydrogens, and we would say that we have 1 oxygen. When we look at sodium chloride here, NaCl, we would say there's no number down here at all. And so I know that because there's no number down there beside them, I know that I have 1 of each of them. And so for this one, I would say I have 1 sodium, and I would say I have 1 chlorine. Going down to example C, again, there's no number beside Na. The other thing that becomes apparent here that I maybe didn't highlight is if it's a lowercase letter, that is not a new element. Only the uppercase letters, only the capital letters represent the elements. So in this one, we have an Na, an H, a C, and an O. Those are all of the different elements included here. And in this case, there's no number beside our Na, so we have 1 sodium. There's no number beside our H, so we have 1 hydrogen. No number beside C, so we have 1 carbon. And there are 3, there's a little 3 subscript beside our oxygen, so we know that we have 3 oxygens. And then looking at FeO, this is the last one. Again, no numbers beside either one of them, so we would say we have 1. Fe is iron, and we have 1 oxygen in this case. If we wanted to say how many elements these are made of, we would look at this and say how many different capital letters are there. So I know that I have 2 hydrogens, which is these are all of these numbers here. All of these numbers are the number of atoms. So atoms are the really, really small part of the actual compounds. So the way that it works is it goes compound down to the element down to the atom. So atoms are the smallest part, elements are the bigger part. So with H2O, we would say that's made of 2 elements, but we would also say that it's made of 2 hydrogens and 1 oxygen, so 3 total atoms. So this is equal to 3 atoms. NaCl is made of 2 different elements, and this one, because there's 1 of each, is also made of 2 atoms. This next one's kind of confusing. NaHCO3. We see 1, 2, 3, 4 different capital letters. So I know that this is made of 4 elements, but it's made of 1 sodium, 1 hydrogen, 1 carbon, and 3 oxygens, which means that this is 6 atoms that it's made of. And then this last one, FeO, 2 different capital letters, so 2 elements, 1, 2 different atoms.